Hello everyone. We welcome you all to AWS User Group Bengaluru meetup today. So we have an exciting session with great speakers getting started in few minutes with an introduction. So before that, I have quite a few interesting information waiting for you. The first one, we have AWS Women in Tech Day 2021 coming up. It's a community edition. Those who were part of last year's edition might know. I don't have to give further details. So please spread the word, register for free, get to be part of the most excited event to inspire, educate, and empower yourself. Okay? Mark your calendar for September 24th to be part of the Women in Tech Day 2021. Here's the link for you to register. So that's the September event. And the next one we have is AWS Community Day South Asia. Last year, 2020, we had the mega Pan India AWS Community Day, which was highly successful and very well received. And now we have got bigger and better coming to you, joining hands with our neighboring nations, giving you a AWS Community Day from South Asia Virtual Edition 2021. So we have Nepal, Bangladesh, Sri Lanka joining along with India. Make sure to register yourself for the event at communityday.awsug.asia. And we are looking for great speakers to listen to your success stories. Please go to the link talk.awsug.asia to submit your proposal. Okay? See you all there in both of the exciting events. And most importantly, like today's speakers, if you want to present as part of AWS User Group Bengaluru meetups, please send in your proposals at info@awsugbla.in to the email address. Okay. So let's get started with today's session. So it's going to be around best practices and lessons learned from Enterprise Level MSK Kafka deployment. So we have two great speakers, Gayatri Balakrishnan and Aruna Kalagnanam. Let's have a quick introduction about the speakers. First, let me introduce Aruna Kalagnanam. Aruna is a tech fellow in the transaction banking group in Goldman Sachs, developing security solutions in the platform engineering team. Aruna enjoys working on distributed systems for the cloud, and her past experience has been primarily in developing application frameworks, API management platforms, and solutions for cloud platforms. And next, Gayatri is a vice president in transaction banking at Goldman Sachs, where she heads business activity monitoring globally. She has 18 plus years of experience in software development, performance engineering, testing, and production management in the finance and web domains. I would also like to introduce Gayatri as our AWS community builder. So, Gayatri and Aruna, we are pretty excited to have both of you as our speakers today, and it's all yours. Let's get started. And those who have any questions, please go ahead and type your questions in the YouTube chat window. I'm going to consolidate and pass it on to Aruna and Gayatri at the end of the session. So let's keep the QA day towards end. Now let's get started the session with Aruna. Aruna, it's all yours.
Thank you, Bhuwana. Thank you very much. Welcome everyone to our session. So I guess just a second while we get set and share the screen. Yes. So on the agenda today, we have yes. Thank you. So on the agenda today, we have an introduction to what is banking as a service and how transaction banking plays the role of a BaaS provider. APIs are an intrinsic part of being a BaaS. So we'll talk about our API-driven platform, and then delve a little bit into the platform aspects of our product by talking about what our micro account strategy is. Then talk a little bit about our Kafka usage patterns, some of the best practices that we have kind of got from our journey so far, the operational tooling and the observability aspects of Kafka that we have built around our deployment, and kind of summarize with it and take questions at the end. So on to the introduction on what BaaS is. So before I sort of get into what BaaS is, I'd like to introduce transaction banking itself to you. Transaction banking is a digital banking platform. It has been engineered from scratch with a cloud native approach. So in a typical business world, we have corporates that have several treasury function needs. They have liquidity management, payments, they have to manage receivables, tax management. A lot of such functions are absolutely necessary for corporates. So transaction banking is, as a platform and a product, is built to help our clients with such services, to manage their cash, to be able to make payments. So we have support for payments for more than 150 currencies, the ability to open and operate accounts. And that's where I'd like to highlight that we have a support for virtual integrated accounts. So just maybe spend a couple of minutes on that. So in a typical corporate, um, there are several divisions, and each of these divisions have their own cash flows happening, payments and receipts that keep happening, right? So in order to be able to manage all of that, a corporate would have to have so many physical bank accounts opened. But with this feature for virtual integrated accounts, it makes it very easy for corporates to just have one physical account and to be able to manage their cash flow between these virtual accounts in a very organized manner. It also makes things like reporting on the cash flow easier. And at that level, in a financial from a financial perspective, one gets a pretty good view of where the transactions are happening, what is outgoing and what is incoming payments. So these are some of the services that we provide as a BaaS platform. And as the name itself says, we are banking as a service. So we expose these services as APIs in a secure and scalable manner. So a typical service has two major players, a consumer and a provider, which is no different even in the case of a BaaS. So we are the provider that expose these APIs. From a consumption point of view, our APIs and services can be consumed directly either by end consumer or through a partner. So to give an example, in the India financial scenario, we have banks that provide that expose APIs using UPI. There is an end consumer like myself, for instance, who wants to do payment transactions, and then we have fintechs like providing services like digital wallets and things like that, and that's a typical BaaS partner. So while I initiate the transaction as a consumer, I would actually be invoking the transaction on the partner's application, which in turn in the background will invoke the APIs on the banks. So a common enough example is using a digital wallet like Paytm's, and being able to move money around or pay for transactions, right? In addition to that, there's been a lot of innovation in that. Fintechs now offer a lot of services, not just digital wallets, but there is a lending platform that's come about. There is FX based transactions as well. So that's kind of the landscape for a BaaS. And what kind of a role do we play? Goldman Sachs transaction banking play, and what is it about this that makes us unique? So there are two things that are required for being a successful BaaS provider. One is the financial expertise around it, and all the backbone of having compliance and risk management and legal risk management as well. And the other aspect of it is to be nimble, secure, and to be able to adapt to needs in a very agile manner. And that's where I think we kind of stand out with our transaction banking product. We are backed by many years of banking expertise and financial expertise. And with transaction banking, we have adopted the latest technologies. We are based on the cloud, and we offer our services as APIs in a resilient, scalable, and secure manner on AWS. So for the rest of the presentation, we will be talking about our architecture and delve into a little bit of details about the platform that we've used, which is AWS, and how we've been able to sort of customize it and glean out unique patterns from our journey so far. So since it's been more than a year since we launched. So we launched on June 16, 2020, and since then we've come a really long way. So we've had 4 or 5 partnerships that we have announced, a growing base of customers, more than $30 billion in deposits, and we are currently in US but rapidly expanding into UK, Europe, and Japan soon. And our resiliency numbers are really up there with 99.5% uptime and availability numbers. So as I kind of mentioned, the way we expose our services is through APIs. So let's take a look at our functional architecture. So right at the top, we have channels, which is the interfacing component with our clients, corporate clients, or partner applications, depending on the use case. And we expose various modes of being able to interface with our services. One is, of course, the UI based one, where we have a portal through which our clients can log in and initiate payments, look at their statements, reports, open accounts, all of those actions. We also have an API based interface mode, whereby partner applications or even client applications directly can make API calls into our services. So after channels, we have the core components of the banking platform. So one of the key ones is sales and onboarding. That's the first one that most clients would interact with. So we have a well-defined onboarding workflow process that helps do the KYC for clients and onboard them. And the core of the whole banking platform is the payment engine. So we have an orchestration engine there, which orchestrates pretty complex payment flows. So and we support multiple rails. So there's Swift, there's ACH, Fedwire. So the orchestration engine is very busy orchestrating flows through each of these payment rails. In addition to that, we have liquidity management that's linked to deposits as well as account servicing, and that's where the virtual account piece comes in. So this is the a very high level view of our functional architecture. And like I mentioned before, the backbone of this is the platform, which we'll talk about later. So this, yes, so the architecture kind of reiterates the major components, but the highlight of this particular architectural diagram is more about, if you notice it, each of these components are in what are known as their own secure accounts and are deployed in AWS regions, both east and west. So we have regional failover as well built in. These secure accounts are kind of critical. I'd like to sort of take a minute to talk through that. Initially, when we started out, we had a single AWS account, but then we soon realized that for scalability, we had to have accounts for each of the components. And that's what we refer to as the micro accounts strategy, which Gayatri will be talking about soon. So moving on. Yeah. Gayatri, do you want to take over? Gayatri, are you there?
Yes. Can you not hear me? Hello.
Now I can.
Yeah. So, what do you mean when you talk about micro account strategy? First, let's just talk about how would you deploy a simple application on AWS. So you first have an AWS account, you set up the VPC, you're going to set up multiple availability zones, create subnets in them, create the roles, IAM roles, deploy your service in a security group. In another subnet, you deploy your database. You have secrets manager for accessing from the compute to the database. Then you have KMS keys to manage it. And then if you want to scale the compute and run it from another availability zone, you are again going to do the same thing there, deploy the compute within a security group. And then you're going to front them with a load balancer and add the entries on Route 53. Then you need certificate rotation to be able to access them. You need a key store to store the keys. You have the certificate manager, the trust store that needs to be managed. You have Lambda for doing some of the housekeeping and running some of the schedules. Probably you have your CloudWatch logs. You would configure certain rules and alarms on them. So a simple application deployment got quite complicated very quickly. Now, you just completed it in dev and you have to deploy in production. You end up doing all the same things over and over again. So as you can see, this is quite a nightmare to maintain. If you're going to keep doing this, it's not quite repeatable. And if you have custom configurations, and you would probably be stuck trying to maintain what is where. And bootstrapping itself with so many services will take you quite some time. So additionally, if you want to have a separation of concerns, you want to reduce the blast radius, having this kind of architecture all within the same VPC, and when there are issues, you cannot minimize the blast radius. So what's the solution to this? So this is where my multiple account approach comes in. Instead of being in a single account, what if we broke it up into multiple accounts? So create a central account where some of the essentials could be maintained. For example, the one on the right that you see. So always you would need your CloudWatch, you would need some automation using Lambda functions, you would need the certificate authority and the certificate manager. So you can keep these as centralized, and possibly in your individual account, have whatever is needed for your particular service, for your particular application. Another way to do this is what we decided was, okay, so for a particular account, what if we packaged whatever was essential apart from keeping the central account, just package whatever is essential for a particular application in a IaaS infrastructure as code, and then deploy it and bootstrap every account with it. So this way, okay, in dev for this service, you needed a compute, you needed database, you needed keys, you needed roles, all of that is bootstrapped, and then the application is deployed. And you just want to promote it to another environment or create another account, all you need to do is just bootstrap with the similar configuration. And you can, if you need two applications talking to each other, it's much easier because you're bootstrapped with the essential services, and you can connect, and the services can talk to each other. So the advantage of this is that we have standardized runtimes. You can have separate bootstrapping for at the platform level. So some of the essentials like security. So you can have OPA policies for the deployment, and enforce certain policies that, hey, for example, only the internet-facing UI account needs to have certain policies, versus something internal doesn't need to have certain other policies. Similarly, if you talk about we use MTLS, so we need to have the trust and key stores by default. So that comes with the bootstrapping, and obviously observability, having the CloudWatch logs, predefined configurations, alarm setup, and probably piping it to Elastic Search to be able to have dashboards on top of the logs. So all that comes as part of the Bootstrap. And you are able to clearly separate the concerns that as part of the platform bootstrapping, these services can be deployed. And additionally, like I mentioned, if it's a web-facing application, it will have certain other needs. So that can be the application-based code, and some internal application may not necessarily need. So you are separating the concerns. You are having standardized runtimes, this environment parity. So for a non-prod account versus a prod account, you can change the configurations and drive them from your SDLC pipelines. So this is why managing using this kind of a strategy made much more sense to us than keeping one mammoth account in which you were trying to deploy everything related to multiple services. So if there was an issue, multiple services would be impacted. And this made much more sense to us, having a multi-account or micro-account strategy. Now, with this context, what happens when you bring Kafka into this whole mix, right? So how do you manage the cross-account connectivity? So in AWS, we have two established patterns. One is the VPC peering, and other is the AWS private link. So just to quickly talk through what are the differences, and then talk through why we chose one over the other, right? So with the VPC peering, what ends up happening is you cannot repeat these setup blocks, and all these services within that subnet would be exposed when you're doing the peering, and you cannot restrict it to only certain services. You can't subscribe to only certain services within that. So these were some of the problems. Another one was, I think there is a upper limit of around 150 connections that you can have. So when you have when you're trying to make it more granular, this didn't quite work out for us. On the other hand, with private link, what ends up happening is you have an endpoint service. First of all, you deploy your application, sorry, and then you have the NLB fronting it. You run an endpoint service here on the account, and here on the consumer VPC, you have the interface endpoint, which connects to that endpoint service. So this way, you can restrict it to as granular as possible, only this particular service within this account or this VPC. For anything else, it goes through a different interface endpoint. So you could scale very easily, no issue of repeating the CIDR blocks, no cap like 150 on the number of connections that are possible. So this made it much easier for us to restrict the access to essential services that are needed. So with this background, with private link, how did we go about establishing the MSK cluster? So what we did is we created a dedicated account for our Kafka cluster, the MSK cluster, and then fronted it with private link for cross-account connectivity. Now, there are two patterns for this on how you end up accomplishing this. So the first pattern is front each MSK broker with a unique dedicated interface point. So the way you do this is for every broker, have a NLB setup and have the interface endpoint service running here. Then this is all within the MSK account. On the client account side, what you do is you create the interface endpoint, and that will be connecting to the particular interface endpoint service that is running on the MSK account. And then you have the client connecting to this endpoint. And finally, you have the DNS entries with the broker name mapping to it. So that way it is pretty easy for the client to actually figure out exactly what it is connecting to. So for every broker, front it with the NLB and have the endpoint service running and have the interface endpoint and map it. So this was pattern one. In pattern two, group all the MSK brokers with a single shared interface endpoint. Now, the problems we encountered with this was every time if the broker port changes, you have to republish, advertise the ports again, and it was an overhead trying to maintain that. And that's the reason we actually went with the pattern one, because it was much easier for us to maintain with the mapping very, very clear for every broker and being connected through the interface endpoint. So having said that, now let's get into how the application Kafka usage patterns occur. Aruna will talk through them.
Sure. So while ours is an API-driven platform, in the backend with respect to the technical architecture, we use Kafka as the messaging system. So typically, users would hit our payment gateway with APIs or through the UI, and then the messages kind of flow through the rest of the components through Kafka, and that's where we use AWS managed service for Kafka. So one of the reasons why we chose Kafka is because we wanted to have an event-driven microservices architecture. And with that, we wanted a mechanism by which the producers and consumers are decoupled and independent and scalable. So Kafka was a very good messaging system to achieve all of that. But at the same time, it also introduces some operational complexity when messages have to flow through discrete components and events have to be consumed. So there are cases where there can be partial failures. Handling such failures is challenging, but it is extremely important and has to be considered right at the beginning so that the system is more reliable and predictable. So imagine if we had a payment coming in, and as I mentioned earlier, the payment has a pretty complex workflow that happens. So a payment comes in, and then the orchestration engine sends events through Kafka to different components. As an example, there is a credit and debit service, then there's a fraud detection service, and every payment needs to go through all of these services before it can be sort of sent out or an incoming payment can be handled. So imagine that the connectivity from Kafka to deposit microservice is down for whatever reason. At the end of it, we do need the customers' money to be deposited, and we don't want customers to, have go through hell asking where their money is. So how do we handle such instances where there could be a transient error or there could be a non-transient error? So with that, I kind of introduced you to the two different types of errors that we have to handle with our Kafka usage pattern. The first one being the transient errors, and these are normally retriable errors. So being on the cloud, services can go through some transient exceptions or issues. So they being network issues, which can occur pretty frequently, especially if there are dependencies on other services, or if there is a dependency on an external API endpoint, that API endpoint can be down because it's not within our deployment, or the connectivity to database can, for whatever reason, just have a temporary blip. Kafka consumers, so if you look at it, Kafka has producers and consumers, right? So from a producer perspective, there is a retry mechanism already built into Kafka. So Kafka has this ability to be able to retry requests. All we need to do is configure certain values properly. And if it's a transient error, Kafka producers will ensure that the messages are retried. If in case they fail to be delivered the first time around, then the retry happens. From a consumer perspective, a normal pattern would be to consume the message off the topic, process it, and then hand it off to another service, or just persist it into a database. So the dependency on processing could be either internally or there could be a dependency on an external service. So if the request is to, if the request depends on an external service, for example, and if that service is down, then how do we handle it, right? So that's where we have certain patterns that we have tried and just wanted to talk through those. So in the picture, we have a topic A and a consumer A that reads off that topic. Now let's assume that there is an issue. So in such a case, the consumer should not just ignore the message and process the next one. Instead, there should be a local retry mechanism. So consumer A would do a retry because the connectivity to the external services is not available at that point in time. So it does retry either with a fixed delay or there could be an exponential back-off delay. Assuming that the connection goes through, then everything's fine. It's the happy path with a sort of a temporary glitch. Otherwise, consumer A would then push the message to a retry topic. So that's the pattern where we set up retry topics for delayed processing. So we can have several retry topics that can handle these messages with a back-off delay. So in the case of retry topic A, it gets moved from consumer A, pushes it to the retry topic A, and then there's another consumer which we call as retry consumer A that reads off the retry topic, tries consumption of the message and processing of the message again, and is able to successfully connect to the external API. And hence, this is one example of how a retry topic helps with the delayed processing, and we're able to just sort of the consumer is able to move on. Now, if consumer A had sort of continuously kept retrying, then what happens in such a case is that it would just block the processing of other messages, hence pushing this message that has been only partially processed to another retry topic to pick up from where it was left off is a good pattern. Sometimes any n number of retries would still not help us. In such a case, we need to have a recovery mechanism in place, either by logging the relevant information and then configuring a dead letter topic where this message would then get pushed to, and we should have an alerting mechanism on that. Sometimes, again, we tombstone that information into a database for manual intervention at a later point in time. So this is a normal pattern. And here I'd like to just talk about a practical scenario of ours within our product where we send notifications to webhook endpoints. So basically, these are outbound calls from our banking platform to our clients whenever there is any update in the status of a payment, or if there is an update of onboarding workflow, any such event that the client subscribes to. So in such a scenario, we have an event consumer that consumes these statuses and sends them to different clients whose webhook endpoint URLs are configured with us. So client A, client B, client C, these are all example clients that are interested in these payment statuses. If the consumer is able to sort of dispatch these events through API calls, then all is fine. Otherwise, in this case, client C is down, the endpoint URL is down, so the connectivity is broken, in which case the event consumer now pushes that particular payment status to a retry topic. And at a later point in time, the consumer comes along, could be the same consumer or could be another retry consumer instance that we can have specifically for this, would consume that event from the retry topic and then send it to client C. And you can see that it's now green and the connectivity is established and the status has been pushed. So with that, we'll also kind of look at non-transient errors. So non-transient errors are where it's not possible to recover from them. So typically they occur when there is a schema difference, where there is a parsing error, or there's a bug in the application. And in such cases, what happens is that no matter how many times there is a retry, the message is just stuck. So any number of retries is not going to help in such cases. So what do we do in such cases? So normally this is where, moving on to the next slide, this is where we would use a dead letter topic to basically push that particular message there. So here's an example of a consumer that gets reads a message of the topic and is unable to sort of um, basically handle the message. So it gets pushed to a dead letter topic, thereby not clogging other message processes that is happening on that particular consumer. And then it is obviously skipped that particular message, so the rest of the messages are handled. And we will look at ways of handling such poison messages. We have tooling in place whereby we can modify the message and replay the message back to the same topic. One point I wanted to mention here is, if message ordering needs to be maintained, then it's very important to sort of redirect all the coal related messages to a dead letter topic. In case where message ordering is not very crucial and is not important, then yes, only the messages anyway by themselves can be pushed to dead letter topic. So here's an example where we have payment instructions that are read by a router, and that router has an error handler. So here's where we are using Spring Kafka. We use an we've extended the seek to current error handler to be able to retry for a certain number of times and then be able to push messages to a configured dead letter topic. So that's what happens in this particular case, where the consumer reads it, is doing a retry with the error handler, and in this case the error handler has retried it a fixed number of times, then pushes it into a dead letter topic. We have monitoring also built in around the dead letter topic, so we immediately get an alert from, and we use Datadog as a service here for monitoring and alerting. So we immediately get alerted, and in such a case, the way we would rectify or replay the messages, I mentioned that we have operational tooling that lets us go to a control plane, look at this message, peek into this message, and make any modifications to the payload if required, and then replay the message. So there was a practical scenario from a month back, I guess, where due to a configuration change, we had certain messages that were being replayed. So the pattern was that there was a consumer that was consuming messages from the topic and then does processing and then pushes the message to another topic. So it was breaking at the point where the message was not getting pushed to the second topic after the processing. So in such a case, we made a fix in our consumer and we wanted to replay the message, and that's where we found the operational tooling to be very useful. We went, replayed it from, and you can give a range of offsets to replay the messages from. So we gave the specific offset of that message that we were interested in. It got replayed, and this missing message was also processed and pushed to other components for further processing. So with that, I think it'll be a good segue to sort of look at how our operational tooling works. Yes, before we move on to that, just wanted to share some tips. So we are essentially a Java shop, so we use Spring Kafka, like I mentioned. We've extended from Spring Kafka's seek to error handler to be able to sort of override it and have our own logic in it for error handling requirements. Then we also get a lot of the chaining of transactions support from Spring Kafka. The other piece that helped us quite a bit is we have lots of components, as we covered earlier, and many of them use Kafka for the event-driven architecture. So having a consistent set of configurations across all of these multiple Kafka clients has helped us immensely. So some of the key configs that have helped us are, we set auto commit to false. So that lets us control when, as a consumer, we can go back and commit the offset. Then access equal to all. there were some situations where x is equal to all was not set, and hence we had no guaranteed delivery of messages. So by setting this, we ensure that all the brokers and the in-sync replicas receive the messages. And we also have the in-sync replicas to be greater than 1. In case there is downtime of any of the brokers, then we would have another broker become the lead broker. So these are a few of the things that have definitely helped us uh, in being able to sort of set up a successful producer consumer combination, and to be able to use Kafka uh, in a pretty durable, scalable manner. So with that, we'll move on to the operational tooling that I was talking about. So this is an SSM control plane that triggers the Lambda, and it gives the ability to be able to do message replay, peek into the message, modify the payload for the message, and then also peek into some of the red letter queues, see what the messages are, modify the schema, and handle poison messages. The key points to note here are it's fully protected, so it's entitlements driven. We have our own entitlement service that controls access to this, so that only the person who is authorized is able to log in and is able to make modifications. The payload is again not fully visible because there is sensitive information. So only aspects that are absolutely allowed to be made visible are done, and we have controls in place to ensure that the payload is encrypted. I guess those are the salient points where this has been actually a boon for us, where we've been sort of able to replay some of the messages. Sometimes in architectures like ourselves, we have dependency on vendor products as well. So it's not always easy to be able to make changes to or introduce patches into vendor products. So sometimes it is important to be able to sort of modify the payload and replay it and have the corresponding processing done. So that's where this control plane has been extremely useful for us. I'd also like to touch upon the observability aspects. So how do we sort of ensure that the messages are flowing fine, there is no block or messages getting dropped anywhere? What is the error rate looking like from a producer perspective and from a consumer perspective? Is there a lag? What does the consumer lag look like? So those are all some of the metrics that we are extremely interested in, to know the health of the Kafka messaging system and the health of all the producers and consumers. So from a Kafka perspective, durability, the guaranteed delivery aspects of it, latency, and the throughput are all important for us from an application point of view. And from an availability point of view, that's already handled for us by AWS. So which ensures that brokers are up and running. And if any of the brokers go down, AWS does bring up other brokers. So from how do we collect these metrics? So like I mentioned earlier, we are essentially a Java shop. So applications are running in their own Java virtual machines. We use Datadog, I mentioned, for monitoring and alerting. So that's where we use JMX agents that are running within the Java process. And there is a Datadog sidecar agent that's running alongside in a container. So we primarily use ECS for deploying our applications. So Datadog is running as a sidecar container, and the application's JMX agent is able to push the messages to the Datadog sidecar container. So the configuration is a YAML configuration. So it is possible to have JMX configurations and set it up in the agent as well as in the sidecar. So once the sidecar collects all the metrics, it then pushes it to the Datadog backend service, from where it's available on a dashboard that we all monitor. And the alerting piece is also linked to PagerDuty. So whenever there is something amiss, we get an alert on PagerDuty and with information about what is the alert and some relevant information, which lets us then investigate and debug further. So from a broker perspective, we have a team that manages the broker. and we have these metrics that are available to us. So what is the health of the broker CPU and disk usage? On an average, what are the number of packets that have been transmitted and received? What is the health of the leader? Are all leaders up and running fine? And things like that. From a producer and a consumer perspective, and that's where most of the applications are interested in, right? So from a producer perspective, what are the active number of connections? And this is per topic. So what is the request and response rate? What is the outgoing byte rate, error and retry rate? So mostly we are interested in the error and retry rate. If there is multiple retries that is happening, then we know that Kafka producer by default is trying its retries. And if there is an error, then we know there has been an error in actually publishing a message to the topic. From a consumer perspective, we're interested in the lag to see if the consumer is lagging behind in the processing of the messages. Again, if there are any connections that have been closed, and the record consumption rate as well. So these are dashboards that we have set up for each of our applications, and we can drill down to these metrics by topic. So this has been kind of really useful for us, and we've been also able to set up alerts based on, say, retry or an error rate. So beyond a particular threshold, then we would get alerts saying, the retry has exceeded so much, or if there has been an error in sending messages to a topic. So with that, going to hand over to Gayatri.
Thank you, Aruna. Okay, so now that we've talked about how the infrastructure is set up, now how do we do business activity monitoring using Kafka? So recall, we talked about the overall functional flow, right? Where we have multiple stakeholders, starting with the client or partner. Then you have cybersecurity, our sales, onboarding, and operations. Then you have the treasury operations or payment operations. Then the liquidity operations, managing liquidity, and also the regulatory controls, tax and compliance aspect of it. So each person in this entire functional flow has a different set of concerns. For example, if you talk about our client or partner, they might have concerns like, hey, can I open my account? How many accounts are open? I posted a payment. Where is my payment? And how many of my payments have gotten delivered? Were there any failures? And you would have cybersecurity looking at aspects like, is there any fishy activity? For example, a client is logging in within a minute from two different parts of the world. Does that look fishy? Are there multiple wrong password retries coming from a particular IP? So cybersecurity would have anomaly concerns like that to detect. Then coming down to the client service operations, they would be concerned about, okay, how many transactions did my particular client make? How many of them were successful? What should I be billing them for? So what is the billing rate and what should I be billing them for? And then you have the overall treasury operations monitoring the overall volumes and values, what has been straight through, how many do I have to manually intervene to fix? For example, something is stuck in repair and I have to intervene and review the instructions. So treasury operations would be considered, considering concerns like that. Liquidity operations, okay, does the client account have enough balance to do this particular transaction? Those would be the liquidity operations concerns. Similarly, your regulatory, compliance, tax, all the controllers, all of them would have concerns like, were there many payments stuck in sanctions, rejected due to some sanctions of fraudulent activity? How many went through repair and have been repeatedly have had to have manual intervention? What have the volumes and values been, say USD equivalent that we received from a particular channel like API or a secure file transfer? How many went out through, say, Swift? So there are all these different stakeholders with different kinds of questions. And that is where business activity monitoring comes in and why it is important. So just to answer these questions, how would business activity monitoring work? So if you recall, payment comes in through the channels, goes through validation, possible sanctions of fraud checks, gets enriched with the required information for it to be executed, and then is finally sent out through one of the rails, say Swift, or say Wire or ACH, any of those. So at each point in this flow, if you recall, each of these are running as separate services in their own micro accounts. They've been talking to each other through Kafka messages across the accounts. So what we have done is we have set up a business activity monitoring application in a separate account, and these the app listens in to Kafka topics. So each of these systems post milestone events onto the Kafka topic, which the business activity monitoring app consumes. And once it has consumed them, it constructs the entire flow of the payment that, hey, okay, it came in through channels at, say, 8 a.m. and then went through all the validation at, say, 8:01. And by 8:02, it was enriched. It was not held for any of the sanctions or fraud checks. It was passed. And at 8:02, it was sent out the door to Swift. We received a Swift confirmation at 8:03, and we are done. So that makes it pretty easy once we have all the milestone events coming in to construct the flow and then expose it via UI where all the stakeholders, operations, product, business, leadership can all come and see, okay, how are we looking for today? So the way we set up this was, like I said, we consume the milestone messages from each of the services, and we've come up with a pretty reusable structure of the event that each of the sources is supposed to post to us. So for example, you just have the source name. For example, it could be the orchestrator, or it could be the fraud service, or it could be the executor service. Then you have the event. So say received, in progress, failed, or successful, successfully posted to the next service. Then you have the status, obviously, whether it was the event was a success or failure, and reasons, particular reasons for it. For example, it was in repair. Okay, what is the reason? So the account number was wrong. So that could come as a free text in the reason. And you have a reference ID. For example, say our API might have a unique reference ID with which they reference it, and that will be internal to that system. Having said that, how do we correlate it end to end? And that's where a parent reference ID comes in. So a parent reference ID would be something that uniquely identifies it end to end. So every system will have its own internal reference ID as well as a parent reference ID, which helps us correlate the payment end to end and construct the flow and depict where it belongs in the flow. And any other additional information that you want to post about the payment can come in the metadata. For example, what kind of payment is it? Is it a credit or a debit, for example? Is it say a return or reimbursement of something else? Is it a check deposit, or is it a wire transfer? So all those data can come in the metadata payload. So that clearly helps us create all those dashboards for the stakeholders in question here to be able to slice and dice the data and be able to see the answers to the questions that they may have regarding the payment flows. Right. So in conclusion, tying it all up, what are some of the best practices we talked about? The microaccount strategy, having redeployable, standardized runtime environments, helps us with separation of concerns, isolation of the various accounts, so reducing the blast radius. Similarly, it has made the security concerns easier. You can easily deploy policies using OPA agents, and you can do certificate management. So you can have certificates that possibly, say, expire every 30 days or 60 days, but then as part of the overall SDLC pipeline, deploying bootstrapping to various accounts as part of the platform base module, you can easily rotate the certificates. So all of these have been the micro account strategy in itself as a building block has been tremendously helpful in us scaling and managing the mammoth infrastructure that we have. And secondly, the broker access patterns, the MSK broker access patterns that Aruna delved in detail on. How do you handle retries? How do you handle when you're able to connect or when there is a dead letter, there's a poison message, there's a dead letter queue set up, and we have operational tooling around that. And similarly on Kafka, what are the configurations you need to do? Do we need to set up a acts all for at the broker level? What part of the configuration is at the broker level? What parts are at the consumer level? For example, don't do an auto commit and allow the consumer to decide when to commit back to the topic. And finally, the business event monitoring, creating a reusable framework and event structure pattern that allows us to add new sources easily and add new kinds of events pretty easily and scale it quickly. So with that, I've provided a list of references. Again, everything we've covered here has been in the public domain. We've presented in a bunch of forums, us and our colleagues. So I've added references for you folks to be able to refer on how we did certain things, at least in the transaction banking context, how we put together the various design patterns to be able to do it in a scalable and repeatable way. Thank you very much.
So I guess we can take questions.
Thank you so much, Gayatri and Aruna. Yeah, let's open up for questions. So there was a question which I want to show it here from Indrajit. Which pops up good to use, Kinesis or Kafka?
Well, I guess both Kinesis and Kafka can handle event streams. So when we started off with our project, which was a couple of years back, we chose to take Kafka mainly because of prior experience with Kafka, as well as the interaction with multiple messaging components in our architecture. The other thing that we also considered was Kafka is as a broker or as a messaging system pattern allows for producers and consumers to be decoupled, so that in addition with the interaction with the different messaging components swayed our decision in favor of Kafka. But if you were to compare both of them do support event streams. Kafka is of course known to be scalable, where thousands of messages can be processed. But if you look at Kinesis as well, it also has the capability to scale. Like I said, those few points swayed our decision in favor of Kafka.
Thank you. So we'll go for the next question. If certificate manager is there, then why you require a separate certificate manager?
Yes, I'd maybe just clarify that particular point. We are using the AWS certificate manager, not our own certificate manager, except that we are using private CAs. So we are using ACM private CAs for all the mutual TLS authentication between services in our setup. So we are using AWS certificate manager.
Thank you. So there's one question from Hemanand Rajendran. How are the clients built for using BAS? What is the building strategy?
So from, sorry, Gayatri, did you have something?
Yeah. So with respect to the APIs, right, for banking as a service, I think the billing strategy across the board, irrespective of whether it is through APIs or through various channels, I think we have a pretty simple structure. So depending on how many transactions have been successfully executed, typically the billing happens. I don't know if you want to add to that, right?
Yes, to add on to that, from an API access point of view, we don't charge for APIs being accessed by our consumers. But what we instead charge for all the services that are used underneath. For example, as a partner, I could invoke a payment API, but for the invocation of the digital means, I'm not charged. But if the payment goes through the payment engine, then there will be a corresponding charge for that. So not specifically for our APIs, no billing for those.
Okay. I do not see any other question. Okay. So there's one from Ramakrishnan. Are you using any transnational producers in the application?
Mm, Transnational producers. I mean, I'm not quite sure what we mean by that.
I guess you probably mean
So
transactional producers, I guess.
Or are you
could we
talking about do we have global payments? Yes, we do. I think Aruna covered that.
Yes, Ramakrishna says it's transactional producers. It could be typo. Probably you can answer from that
Yeah.
transactional producers perspective. Yes.
Yes, we do use transactional producers in our architecture, in our application.
Thank you so much. That's okay. Typo happens, Ramakrishnan. So we'll wait for a couple of more minutes to see if we have any questions. But by then, thank you so much, Aruna and Gayatri, for a wonderful session. It was a great learning experience to understand the best practices and also easily knowing the lessons you might have learned hard way, right? So it was pretty simplified format for us. Thank you so much for your time. So we have another question from Sunil. Let me show that here. So you have a complex system, and how do you manage Kafka upgrades? Good one.
That's a good one. So, as we mentioned, the major part of it, the broker aspect of it, is taken care of by AWS, right? So we have AWS that maintains the brokers for us. So periodically we get intimated about any upgrades, and usually there is a downtime with very low traffic during very low traffic times. That's when the upgrades happen for across the brokers. And if it necessitates that we have to upgrade our client libraries, then we'll accordingly do that.
So that's
But the
the
bulk of
advantage going for managed
yes,
services,
yes,
right?
that's the advantage of it. And the bulk of the heavy lifting is done by the AWS cloud provider for us.
Yeah. And again,
Awesome.
since it's
Thank you.
in its own dedicated account, so it's literally the downtime for that particular account where the cluster
Yes.
is deployed.
Yeah, that's another good point. Yes.
Having multi-account helps this way.
Definitely.
Okay. So we have yet another question. Hope that answered you, Sunil. We'll move on to another question from Ramakrishnan here. How about streaming? I was using KSQL.
I'm not aware of a use case for that, right? We're not using that. No.
Okay, we'll move on to the next question. So we have Hemanand again here. What is the, okay, let me show that. What is the average volume of transactions that go through the system? Aren't we, should we say that
My
or not? Up to you.
my favorite topic. So let me put it in the context because I handle the business activity monitoring. So it's almost like picture probably tens and thousands, but business activity monitoring multiplies that by for every particular transaction. We are looking at like 50 events or more from each of those unique services. So we are operating at quite some scale. So every time we are increasing the number of transactions, correspondingly, we would be doing at least a 10x upgrade on our entire monitoring infrastructure to be able to handle that. Beyond that, specific numbers, I'm sorry, I don't think we are at liberty to share.
Okay. So I also have a question. How do you handle the performance testing? Stress, I mean, do you conduct stress or load testing? Might be doing it, right? To what scale you would go beyond your normal load to test it
So
when
we
you're
we have
scaling
a
up?
we have a performance and load test suite that we have internally developed that allows for different types of payments to be played. So, like we mentioned earlier, we support Swift, ACH, Fedwire, different types of payments. So, this performance test or the suite that we have simulates these payments, and it's able to sort of fire all these payments at the desired level. So it basically takes a bunch of transactions and bunch of test accounts and things like that, and it is able to play them through, and we can measure the performance. And initially started off being only for payments aspects. Now with API support and everything, we are able to play it in the same flow as the API payments as well.
Okay, thank you. So we have another question from Lokesh. How do you handle scaling?
That's kind of like a broad question, I suppose. How do we handle
So
scaling?
you
So
use so many services, right? As far as managed services are concerned, AWS takes care of scaling perspective.
yes.
But for other services, if you want to add anything in short, yes.
So I guess, I mean, Gayatri, you can add on, but maybe I can take a first shot at it. So we have different components. They're all housed within their micro accounts. So at a component level, we know the performance of these individual services. And through our load performance testing, we would have a pretty good idea of those. Now, there is a business team that also interacts with our clients, and they have a fair bit of an idea of what the load is going to look like, the number of payments that we will receive, and things like that. So depending on those inputs, it's a combination of monitoring the performance and being able to sort of scale up on demand as and when we get requirements from our business and product teams. So that has been the model that we've been working with. But I think going forward, we will be we are consciously looking at our uh, SLAs, our latencies, and we are working towards sort of scaling our instances a lot more with these performance tests that we are conducting. So yes,
Thank you.
sort of a roundabout answer to that question, but yes, it's constantly constant evaluation of where we stand, doing tests, and then being able to sort of react to the test results.
Okay.
Yeah.
Sure, we
Uh,
understand that there is no comfort zone that we can arrive at this, right? It's an evolving thing.
Yeah. So, I mean, if I may add to that, are we doing auto scaling? At this point, no, we are being overly cautious. Like Aruna mentioned, based on what are the contractual SLAs and anticipated volumes, we tune our performance tests and accordingly decide the scale that we need to deploy with. Um, but auto scaling is not done at this point.
Sure, thank you. We'll give one more minute. We had a lot of interesting questions, right? Is there anything else that you want to add? know you have shared a lot of insights. We'll hold on for another 30 seconds. If you don't have any questions, then we'll wind up the session. So while we watch, you can also look at the banner. Please make sure to get into the corresponding website to register yourself for AWS Women in Tech Day 2021, which is coming on September. Also, we have AWS Community Day South Asia, which is coming in October. Please sign up and enjoy the sessions. I think we are good. Thank you so much, Gayatri and Aruna, once again, taking time to share your experiences and lessons with us. Looking forward to have many more interesting sessions together in future.
Thank you.
Thank you. Looking
Thanks for the
forward
great
to it.
opportunity.
Yes, it's been great.
Nice.
A plug for AWS community builders. If any of the group is interested, applications are open. That's a great place to connect and share best practices, learn from others. So definitely, if you are a user, you should consider. I've been part of it, and I've learned a lot even as part of the
So, do
community.
you want to add a few words about, as a community builder, how we have been the learning journey, Gayatri? So, you brought up
Uh,
an amazing point.
I've met people like you, folks like you, for example. I think we've interacted a lot about.
I'm honored.
In fact, I think Women in Tech Day was the first time I heard your session. So that's where the journey started. And then subsequently, I got chosen for the Community Builder program. So there are various streams there, serverless. I'm part of the management, governance, and migration group, the databases. So you can pick the stream that you want. Typically, it's more of an interest on what do you like. Do you use the services? Do you have best practices to share? How do you kind of want to interact? Have you been making your own content about tutorials about it? So that's the way the whole model is structured. So it is more to have connect with like-minded individuals, similar problems, a lot of the scale problems. In fact, I had interactions with some folks in the community. Hey, how did you do it in your firm, and how could we do this better? So that is where it has helped a lot, and I would definitely say give it a shot. The applications are open. I think it's a couple of times a year the applications open. And you have previews to sessions, so definitely I think you should go for it if you're interested.
Thank you so much for sharing your experience as a community builder, Gayatri. I'm going to share the community builder program related link over this YouTube so that people can register and get benefited like you and become a very good AWS developer. Thank you so much once again. And thanks to the viewers as well for making the session very interactive with a lot of interesting questions. Thank you.